Do you know, Ohm's law is not the fundamental law of physics because it is not derived. The law was discovered by George Ohm empirically. On the other hand, Newton's laws of motion are the fundamental laws because they are derived from the fundamental symmetries in nature. Well, that does not make it of any less importance. Let us get into a simulation and perform an experiment to verify the relation of Ohm's law. Let us study the dependence of current I flowing through a resistor on the potential difference V across its ends. In this experiment, we will determine the resistance of a resistor and verify Ohm's law. Here, in the experimental setup, a resistor is connected in series with a battery, a switch, a rheostat and an ammeter. A voltmeter is connected across the two ends of resistor. Note that the ammeter should be connected in series with the resistor, while voltmeter should be connected in parallel with the resistor. First, let us know the range and least count of the given ammeter and voltmeter. The range of the given ammeter is 0 to 1 ampere. Since there are 20 divisions between 0 to 0.2 or any two big calibrations, the least count of this ammeter is 0.01 ampere. Similarly, the range of the given voltmeter is 0 to 5 volt and its least count is 0.1 volt. If there is any zero error in either of the meters, then eliminate it before performing the experiment. We can select any other resistor from the pop-up menu. Change the EMF of the battery. Let us change the current flowing through the circuit with the help of rheostat. Observe the changes in ammeter as well as voltmeter readings. Record the data in the observation table. Plot the corresponding point on the graph of potential difference V versus current I. Here is the calculation for resistance R, which is the ratio of potential difference across its end and the current flowing through it. Let us record another set of data by changing the current flowing through the circuit with the help of the rheostat. Repeat the process and record other sets of data. Find the ratio of potential difference and current for each set of observations. Simultaneously, observe the corresponding point on the graph. Let us examine the inferences drawn from the experiment. Graph of V versus I is a straight line passing through the origin. This verifies Ohm's law. According to Ohm's law, the current flowing through a conductor is directly proportional to the potential difference across its ends, provided the temperature remains constant. Mathematically, V is directly proportional to I, or V is equal to IR, where R is the constant of proportionality. It is known as the resistance of the conductor. The slope of the graph gives the resistance of the selected resistor. Verify that the resistance value calculated from observations and measured from the graph are nearly equal. Now let us summarize. According to Ohm's law, the current and voltage vary linearly. Resistance is the constant of proportionality. The slope of the VI graph gives the value of resistance. So, this was a simulation video on Ohm's law. We observed a new quantity, resistance, during the study of the relation between current and voltage in a circuit. What is the root cause of this resistance? And can we mathematically formulate it? We will discuss that soon. Stay tuned.